All right, let's see how you did on your first assignment where you did the panic model and you did the full interval. So now, here on this first one, we were talking about P equals. So don't forget to put your P equals in. That's because you're defining the variable, not because it's P for the panic model. So P is the proportion of state universities seniors who say that they have cheated during their college careers. So this is present tense. So this is the current proportion of seniors who say that at one point or another they had done something in the past. But this is present tense. So that's a very important thing to look for. All right. So random, these were stated to be 150 randomly selected seniors. 150 is less than 10% of all state university seniors. So we don't have a true P. So we're using our successes and our failures. So here is our successes and failures. Okay. And so the approximately normal model applies. We have a 1 proportion Z interval. That's what you're putting every time because that's all you know about. So now I went ahead and I always just kind of put my information over here to the side. My P hat was 93 out of 150, which is 0.62. My critical value, we were asked to be 95% confident. So that's inverse norm of the one tail of 0.025. And then my standard deviation of that 0.62 times the opposite of that over 150. So here's that statistic is your P hat plus or minus that critical value times that standard error of the statistic. And then you do one where you plus and one where you minus to get the two parts to your interval. And then you say, I am 95% confident that the true proportion of state university seniors who say, so in present tense, the ones who currently say that they have cheated in the past is between 54.2% and 69.8. I usually just round to the tenths place when I get it into percent. Now, would I be surprised if the ethics committee claimed 65% of all state university seniors have cheated? And no. And your reason for that is because this 65 is within my 95% confidence interval. So I do not have any, so it's a very plausible amount. I don't have the evidence to say it could be somewhere else. All right, next. This is the proportion of all cars that have at least one safety violation, not the proportion of cars that were checked. That you could say the proportion of cars who get checked, but make sure it's not referencing the 134 cars. That's what we have to be mindful and guard against. You have to make sure this is about all the cars, not the ones in the sample. That's what we're guarding against. We don't need to infer about the sample. We have that information. We need to infer from the sample about the rest. Okay. So here we are assuming randomly selected 134 cars, 134 is less than 10%, and here was our large enough, at least 10 successes and failures. Approximately normal model applies. We have a 1 proportion Z interval. I don't know why I know why it keeps, I guess I forgot to erase that when I was doing my stuff. Okay, there was my P hat of 0.10. I think it was like 0.0104 or something, and I decided to just, I just did 2 decimal places. Inverse norm of one tail for 90% confidence, 50% in a tail. And then there is my standard error of the statistic. So here you put them in the formula, plus and minus. Here is my interval. So I'm 90% confident that the true proportion of cars that have at least one safety violation is between 5.8% and 14.3%. Now, would 7% surprise you? And that'd be no. I should have made one of these questions say like 15% or 5%. Would 5% surprise you? And that answer would be yes. 5% would surprise me because it would be below my 90% confidence interval. Okay. So that's whenever it gets interesting to us and we would be surprised if it was not in our interval. Okay. All right, here we go. We have a margin of error and we're trying to see what size sample do we need to have this accuracy, 0.04, okay, with this confidence. So here, and then they do give us, so they're trying to estimate for New Zealand, but they're using the American guidelines. So that's the p hat that they used. And so then there's our standard error right here. So here is the formula that has to be set up. Our 0.04 for the margin of error equals the critical value times that standard error with the n unknown. So then I did this all on my calculator, and if you're still having trouble with the math on this, and with the rounding, no rounding, keeping it all in your calculator, then there's that. It rounds to 385. Okay, but this question says, suppose they do not want to use the American estimate. They are not satisfied by using the American estimate to approximate their 16 to 20-year-olds. So in that case, then we are using 0.5 because we had no other estimate to go by. And so remember, that's the largest possible product that we could have here, so to be on the safest side, so that we're not having too small of a sample. All right, so we want to have the same criteria, same margin of error, same level of confidence, but we had 0.5. Look at what the difference is. It went from 385, needing 385, to 601. 600 is not enough. It has to be, this is the minimum, so 600 is not enough. It needs to be 601. All right, so now let's take a look at this. When one compares a 95% confidence interval to 99, so I know 95 is here, 99 will be wider, okay? The sample size does not need to be known to tell the difference. The sample proportion will not be the cause of making the 99% confidence interval larger. It's that critical value. That Z star is going to be a larger number because you are a farther out. All right, since the same data is used for both intervals, the 95% will be wider, so the 95 is not wider. The 99% one is wider, so that's why D is the answer. 8. So here we are doing this. They are actually just having us do this problem and leading us through this and asking us, what do we not know, or what information do we not have to be able to do this? Let's see. A sample of 1,000 adults. So I have my N. Okay, so I have N. Showed that 31% of them are smokers. So then that gives me all of this. So here I have all of this. To estimate the proportion of people in the entire population who smoke, what additional information would you need? So I need to be able to get this margin of error. Let's just do p hat plus or minus the critical value. So if we're talking about doing an interval, and then that standard deviation, okay? I've got this. This is good. I've got this. What I do not have is that. So I don't have that critical value because they have not told me how confident to be. So that's what's missing. All right, next. Here we are estimating with 4% margin of error. Whoa. And look at this. So I had to I'm so bad at subtracting, so I actually got my calculator out on this to make sure that I was right. Okay. Because look at this unusual confidence level. So this is kind of one of those questions that forces you to make sure you know how to get that critical value, and it's not just a number that you have memorized. Okay? So if you have 99.6% in the middle, then when you subtract, this 0.4 is split between the two edges. Okay? So if you divide that in half, then that's 0.2% on each side. So 99.6% in the middle, 0.2% on either side. 0.2% is 0.002 as a decimal. So I inverse normed 0.002. And that is then how I got that critical value of 2.88. I had to use 0.5 for my p-hat. Okay, and then I solved. I think it actually ended up coming exactly out to 1296, if I remember correctly on that problem. Okay, here, either that one came out exactly or, yeah, I guess this one did not. Okay, so how large of a sample do we need to ensure a margin of error of 0.03 with this critical value? And we had to estimate, here we put our 0.5 in there, so then we did our math. Notice that it's just a little over 1,067 that is needed, so it has to be 1,068. And that's it. Okay, so that takes us to the end of our assignment day 3. The notes for today are very tedious and tricky in the wording, and I'll get to that in the next video.